Hi, hello, hello. So, today it's a bit late in Japan time. It's 12:30 a.m. on Sunday, and would like to start this week's tutorial live for Houdini for today. And the topic today that I'm gonna show you today is to create how I have created this kind of muscle-like fiber strings with an animation, something like this, setting a starting point, and then you can procedurally create an animation going from the starting point to the farthest point, creating a line animation like these. And you can also set multiple number of points, and the result you get is instant. In this case, you have 4 starting points to create a string, and this is the result you get. And I'm not using any solver here to create an animation, so the result you get is pretty instant. These, so you can just go back and forth anytime you want, and it could work for geometry which doesn't share the connected geometry like this rubber toy. The geometry, like here on the leg part, is not connected to the body, but it could still work with this setup, just like this. So this is what I'm going to show you today. First of all, creating these curved network on top of the geometry by setting a starting point, then convert it into a pipe geometry like this to recreate it as a muscle fiber. Now I do have a little bit of problem with using this polywire, but let's see how I have created this one. Right, so that's what I'm gonna show you how to do this today from scratch. Okay, the method here is a bit new, but it's kind of related to what I have been doing in other tutorials. So if you have watched anything that I've done previously, maybe you have some familiarity with it. Though I'm just gonna explain it from scratch. So first thing first, I'm going to create a geometry node. Then let me also save this to the today's folder. Just this one. Let me know if you can hear my voice. Hopefully it is. Alright, so first thing first, I am going to create any test geometry that I would like to convert it into a muscle fibers. So since the rubber toy has a unconnected geometries, maybe this could be a great test case. So once I be able to use this for the testing, then maybe probably the other geometry could be used for the same setup. Okay, so that's the reason. Now first of all, I'm going to delete the material attributes so that I can work on the flat white surface, so that I can work on the geometry effectively. So I'm going to use the attribute delete to delete the material attribute. Alright, now let's also use the connect node to know how many isolated island you have in this geometry. So I'm gonna use the connectivity. Oops. Connectivity for points, I guess. Then let's check the geometry spreadsheet, see how it looks like. So I have class attribute that are being created by connectivity, and I have from 0 to 9. So that means I have 10 isolated geometry for this rubber toy. Okay, so those geometries are not connected with edges. Okay. Now I am also going to create some points which lies on a 3D space, which is going to be used as a starting point position for the muscle fiber string. Okay, so this can be any place. I'm just going to add one or maybe multiple points, maybe 2 points, and place those points to anywhere you want. Just gonna move these. Let's check. So let's say one of the point lies on the tail, somewhere close to the tail, and another point goes somewhere close to the nose. And maybe I can shift the X position a little bit. Alright, so let's see how this goes. So what I would like to do here now is to create a trail, some kind of trail network or trail curve going from the starting point to this direction and so that it can fill the whole surface in some way. So in order to do that, we do need to define like in which direction should this curve go, right? And in previous tutorials, I have shown many ways to create this kind of trail. One way is to use the principal curvature. One way is to use the gradient, and so on. This time, I am going to use the gradient, not for the point position, but gradient for the surface distance from those point positions. So, which means I am first of all, I'm going to calculate the geodesic distance, which means the distance on top of the surface from a specific point position. So in this case, I'm going to calculate the distance. Let's say this is the starting point position. I'm going to calculate the distance for each of the point on top of this geometry to this point, and calculate the distance not linearly, not direct distance, but a geodesic distance, which means the distance on top of the surface. So meaning you're going to calculate the distance like this. From this point to this point, I'm going to calculate the distance of this trail curve. Okay. And if I have multiple points, then I'm going to get the shortest distance. First of all, calculating the surface distance or geodesic distance for any specific points on top of the geometry to this point, and also for this point. Then you get 2 distance values, one for this point and one for this point, and just pick the minimum distance out of those 2. So obviously this one should be the shortest. If you are looking at this one at this point, then I'm just going to use this surface distance for this point. If the point comes somewhere around here, then this will be shorter, so I'm gonna use this shorter distance as the result of the surface distance. Then place those or store this distance value as an attribute to each point, then use this distance to calculate the gradient vector using a measure node or something. Then I can use that vector value to use it for the guide to move the point from starting point to those specific direction to create a space filling curve. Now there are some tips you do need to do in order to fill the space using those directional value or gradient value, but I'm gonna show you later. But that's what I'm gonna do for this step, and it's not that hard to do, it's pretty easy to do. So let's see how we do this. Okay, so first thing first, let's calculate the surface distance for each of the points on this geometry to these 2 points that I have created manually. All right, so I am going to use the point wrangle for these geometry and calculate the surface distance or geodesic distance, and referencing to these 2 starting points, which is somewhere around here and here. We raise up the size of the point a little bit. All right, now let's do this. Let me also open up the Vex function page to see what kind of function that I'm going to use for the Vex. Now, of course, this is the Houdini algorithmic live. I'm using Vex a lot for this tutorial. So in order to calculate the geodesic distance, you can use the function called surface dist. Yep, this is it. And it's pretty easy to use. So you define the geometry input number, the point group to generate the point group to search for, and the P attribute could be a point position, I think, and search PT could be the point number to start. The closest point number is the point number you retrieve out of these PD group. And distance metric, you can just choose surface in this case in order to get the geodesic distance. So keep that in mind, and let's try to calculate the distance, surface distance. All right, so since we have 2 points or multiple points coming from the second input right here, so the first thing I'm gonna do is to create a for loop so that I can calculate the distance for all those points available. Okay, so get the number of points from the second input. Now, since I have 2 points here, the loop should run twice, and for each loop I'm going to calculate the surface distance. If I'm looking at this point, then calculate the distance from this point to around here on top of the surface, and from this point to this point on top of the surface. Now, if we are looking at the geometry which is not connected, then actually we cannot really calculate the surface distance, because the surface distance can only work on the connected geometry. So if we are looking at this point, and if the starting point is at this point, then these geometry is not connected, so the surface distance cannot really be calculated. So what I'm gonna do is to, if what I'm gonna do here is get a condition if the starting point is not placed on top of this same geometry, same connected geometry, then just move the starting point to the closest point on top of the connected geometry. Then use that as a starting point to calculate the surface distance. So that's what I am going to do. And to do that, you do need this connectivity information. Okay, so that's the first thing I would like to do. So let's do this. Inside a for loop, I am first going to get the point number on top of the surface, on top of its geometry, which is closest to the input points, like this point and this point. Okay, if we are looking at this point, then the shortest point number should be somewhere around here. But as I said, if we are looking at the point on the disconnected geometry or some other island, then these points should be projected to somewhere around here instead of this point. Okay, so that we can calculate the actual surface distance on top of the surface. So we could just do that by using a near point function together with the point group filter. So first thing first, let's get the point position from the second input. At I. So I'm going to do it for each loop. I'm going to do the same operation each loop. The first loop, maybe probably for this point, and the second loop, probably I'm going to use this point to calculate the distance. Right. So for the first point, I am going to get the nearest point on top of the surface using the near point. The surface geometry is at the first input, so it comes 0. Then here comes the filter that you need to set. I need to search only on the class attribute which shares the same class attribute on the current point So the current point which is working on this point wrangle, all the points should have this class value. So only if the class attribute is same as the current point's class attributes, then you can use this new point. Like that. Okay. Hopefully this makes sense. And then you can use the position to search for the nearest number. All right. Now that I get the nearest point number for each of the point on the geometry, I can now try to calculate the shortest surface distance. Now in order to do that, you do need to have a empty variable called for integer to fill in the closest point number. Okay, now let's calculate the distance using the surface dist for 0 input, the first input, and then the group that we're going to search for is actually a NPT, only this NPT value, which has been retrieved like this. Okay, so this is the goal point, and we have only one goal point for each points on the point wrangle. And then we're going to use the at p, the point position, as the point attribute for the shortest distance or surface distance. Then the starting point is the PT number, the current point number. Then you get the output, say PT. Then finally you determine the distance metric, which in this case use the surface. Alright, now you get this distance value for each of the point, which runs on top of the surface. And you're going to repeat this distance calculation by the number of points you get from the second input. So, and what you want to do is to get the shortest or get the smallest distance value out of these loops. So let's give a min distance variable starting from a really big value. Something like this. And then create a condition inside a loop. If the minimum distance is bigger than the distance currently calculated, then update the minimum distance with the distance that has been calculated right here. Or to make it short, you can also say minimum distance is equal to the minimum of min distance or distance. Maybe this is a bit smarter. Right? So for each loop, it will look for the shortest distance. If the minimum distance is smaller, then just pick that one. If distance is smaller, then pick that one for the new shortest distance or minimum distance. And finally, you'll get the shortest, the closest surface distance. Then that's the one that I'm going to apply as a current distance attribute. Just like this. Okay, and let's check the geometry spreadsheet for the distance. And let's try to colorize this to see how it looks like, to check whether if I have done the correct things or not. Right, so let's say I am going to color these using a distance for the point. Okay, now looks correct, though I don't really know the maximum value for the distance right now, so let's also have that promoted using attribute promote from point to detail, get the distance and get the maximum value, change this to distance max, keep the original. Then going back here, you can, for the maximum value, you can get the detail value. Plus OP input. And the name was dist max 0. Okay, got the correct value here. So this is the maximum value. And let's also change the color to infrared so that I can clearly see from the starting point to the furthest point. Now the starting point is where you have this purple-like color, and the farthest point is where you have this red color. Okay, so currently I have 2 points, which is state as the starting point position, so those points have the color purple, and all the other unconnected shape also have these purple colors starting somewhere around here, probably which is close to this point. Same with these legs, should be using this point as the minimum distance. So starting from this point, you have some distance on top of this surface, and so on. Okay, and if I change the point position of these starting point, I should be able to see the color changing, and those colors are defined by the distance, the surface distance. So I can clearly see that I am seeing those changes, and I think this is working just fine. Okay, looking good. Okay, now let's see. Let me just do with this setup. I have 2 points, one on the leg, one on the nose. All right. Now that I have distance, it's time to actually create the directional value, the vector value, where the line or where the curve should run through from the starting point. Okay. What I would like to get is the curve running from this starting point to the furthest point running on top of the surface. Now if I just do that using a gradient of these distance, there is a bit of problem with that. I'll show you what I mean by that. So first thing first, in order to create a directional value going from this point to the furthest point, meaning from the purple color to the red color, you can first of all calculate the gradient for each point. Gradient means you can gradient is the differences between two values. In this case, we are looking for the differences of these gradational color or gradational value, in this case a distance. So if there is any differences in between the point next to each other, then the vector value is going to be created, and that is the gradient that we would like to get here. In order to calculate the gradient, we can use this measure node, make this point and make this gradient, and instead of using p, I'm going to use the distance to calculate the gradient. And if we look at the arrow, it is showing how the direction is being created, going from the smallest value to the biggest value. So starting somewhere around here, which is the starting point, the arrow is going on top of the surface like these until some endpoint somewhere around here. So that's the direction that I would like to use in order to create the curve, the trail curve or the fiber curve. Okay. And sounds easy, but not so, because one of the possibilities you can use, one of the methods you can use these gradient in order to create the trail curve running from the starting point to those endpoint. You can use a, for example, solver for points somewhere around here. Maybe let's create several points on top of this surface and use that as a starting point, and use the gradient on top of the surface to move those points to a goal. And let's see how that goes. Okay, so I am going to I'm just gonna test this out manually. So I'm going to manually pick the surface by deleting it. Okay, and I'm going to use the scatter node to make it as a starting point position, maybe having 100 points to start, right? And let's also apply some IDs to each of the points so that I can later on use that to create a trail curve. So for each of the point, I'm going to apply an ID retrieved from the current point number. Okay, now these are the tests. Connect it to the solver and also have this gradient surface as a guide, as a reference connected to the second input of the solver. Now go inside the solver, I can try to move those points based on the gradient. Okay, let's do this. I am going to use the point wrangle, connect the reference to the second input. Now, what I'm gonna do is to first of all get the gradient value on top of the surface, which is close to these points. So I can either use UV sample, or since I am, yeah, maybe I can use the UV sample. So vector gradient value is equal to UV sample from the second input. Let me check the parameters. Okay, so 1, and what I'm gonna get is the point gradient vector value, and then what I'm gonna use as a UV is point position, and then use the current point position to actually get the sample value. Okay, now that I have got the gradient value, let's move the point position to this direction. First of all, I'm gonna normalize this gradient and move this with a little bit of multiplication for each frame. I don't know how much I need, so let's say 0.1 for now. Maybe that's too much. 0.01. And I gotta say plus equal so that I can move the point. Alright, and after I have moved the point to that direction, I gotta make sure that the point is kept on top of the surface. So let's also use the ray node, or maybe I can just use the vex functions to make this kept on top of the surface. In this case, probably using minpos function. So at p is equal to minpos at p, like this. Okay, in this case I don't really need a ray node. Alright, let's see what happens. If I play it, I can see that the point is running on top of the surface, and let's check out the trail, how those point has been moved using the trail node. Change the trail length to the based on the frame, and this is how it looks like. Okay, and let's also create a curve out of these points using an add node for the polygon, by group, by attribute, use ID, right? And let's start this from the first frame, see how the trail looks like. Now you can see that there's a bit of problem, and problem is that if I start from a single point somewhere around here, I do see a lot of area that wasn't reached. Okay, you see that all those positions on the tails is not missing. A lot of the surface is not being used for the trail, even though the curve from this point looks okay, but this is really not what I want. What I want to have is to run all those particles on top of the surface equally to create an equally distributed curve. Okay, so to do that, we need to rethink how these points should be set up. Now, one of the idea that I could think of is to not starting from this specific point, but starting from all over the place on the surface, just like this. Let's make this 1000 points. And let's see what happens with this setup. Okay, if I start from all those points on top of the surface, what you get is something like this. Now this looks okay, but there is still a bit of problem, because since we have started from in middle of the distance value, we cannot really actually see the actual trail going from the very starting position, which is somewhere around here, and which is somewhere around here. We have a bunch of curves starting from a random positions. Now sometimes it might be okay, but in my case I don't really like it. Okay, so how do we do that? How do we create a continuous curve going from start point, but at the same time pass through all those possible surface points, then go to the furthest point position? Now, in order to do that, one idea is to just create additional curve going into the negative direction, negative gradient direction from the same point position. Okay, so currently the point is going from this point to this direction. If I'm looking at this curve, going from this point to this direction, but what if I have another point on this direction running on this direction as well? Then I'll be able to get two types of curve running from each of the surface points, and in the end, if you connect those two different curves or two separated curves joined together, then you'll be able to have a point, the curve that goes from the very starting point to the very end of the curve using the gradient value. Okay, so that's the trick that I would like to do here. Let's see, and let's do that. Okay, so in order to do that, you need to have a two starting point. So for each point, so that means you need to have duplicated points on each point position, and then one of the point goes to the positive direction of the gradient vector, and one of the point goes to the negative direction of the gradient value. That's what I'm gonna do here. Okay, so to do that, I can create a group value for each of the point. One group can have a point group called forward as a point group, and another group of the point which is at the same position can have a group called backward, just like that, and then merge these together. Now you have a duplicate point which lies on the same point position. Okay, now that's what I'm gonna use to actually do the simulations. Now currently I'm using the solver, but later I'm gonna get get rid of this solver. The solver is just for the testing purpose. All right, now to hide the solver, let's go inside and see what I need to do. So currently I have two types of points. One goes to the forward direction and one goes to the backward direction. So we do need to make some conditions which point goes to which direction inside this wrangle. So let's name this move, and let's write some value. First thing first, I am going to calculate the gradient value, multiply by movement factor right here. Okay. And also normalize this beforehand. And just delete these, or I can just left out just like that. Now here comes the conditions. If the endpoint group forward at ptnum is equal to 1, then go to the positive direction of this gradient. Now if not, if it's inside the backward point group, then go to the negative direction of the gradient. Alright. And project to the surface. Okay, so that's just it. And let's see how this goes. The problem with this one, I mean, currently I think, now it's running. Cannot really see if it's, cannot really say if this is okay or not. So let's show up the trail and make it as a curve. Okay. Okay, I see a bit of problem. That is because of the order of the point. Now one of the points goes to the forward direction from the center, and one of the point goes to the other direction from the center. So obviously we do need to change the order in order to create the correct line curve, or the curve, the straight, the path curve. So looking at the trail, we do need to reorder some points based on if it's backward or forward. Let's do this by first of all splitting the points to forward group and backward group, and either one of the group should be reversed in terms of the point order. So I don't know which one should be reordered. Let's try with the forward one. So I'm gonna use the sort and make this reversed order for the point. Then merge this back as one node. Then try adding as a curve. Okay, I still see some problem here, so probably this was not position. Maybe if I reverse sort the backward, then now it looks like a straight curve, one continuous long curve. Now that looks good. All right, now now it's looks okay. If I play it, I can now see continuously created, continuously running curve going from the shortest, going from the start point somewhere around here and somewhere around here, going to the both direction, creating one really long continuous curve from the start to the end. Okay, now the color looks a bit messed up, so let's recolor this one by referencing to the original surface and just use the attribute transfer. Now the color looks okay now. And if I play it, looks just fine. Now the problem here is that the animation jet that I have just created is not really an animation that I wanted. The correct animation that I really want is the animation going from the start point to the end point, or vice versa. Currently, the animation starts from the middle of the point, middle of the curve, and going to the both direction. That's not really what I want as an animation. So what I am going to do is to first of all connect those two different polyline as one curve, then use that polyline to recreate the animation that I really want. So for those reasons, I don't really need to use solver because I don't really need these animation at all. So instead, I can just use a for loop with the recursive option on or feedback loop option on, so that I don't really have to rely on those frames to create those initial trail curve. Okay, so let's use for each number. Make this as a fetch feedback, and maybe I can keep this as a merge each iteration, I think. And then let's connect this one right here instead of the solver and go inside the solver, copy this one, paste it right here, and let's reset the cache. Alright, now I'm also do need to refer to this the surface with the gradient value connected to the second input of this move. Alright, now it looks pretty much the same. Now only thing I noticed is that I do see some gaps in the middle of these point array. Okay, so that is because the point is moving from the first frame or the first iteration, so we do need to kind of skip moving if the point is at the first iterations of the loop. So I'm going to connect this for each count to the third input and then check the iteration and move the point only if the iteration is more than 0, or yeah. So detail iteration is more than 0, then move the point. Alright, now I have a middle point filled in. I should be able to create the curve from those points. I think I still need to reorder those points, so let's and I don't really need a trail anymore, so I can just need to connect this to this split, and let's see what happens. If I look at the curve now, seems like the order has been messed up again, so let's change this sort to the forward. Now it's being fixed. Okay, that looks good. And That looks okay now. Now it has been created as a one continuous curve going from start point to the end point. And by increasing the number of loop, I can also increase the length of these curve. Maybe making it 200, it should cover the whole surface pretty much. All right. And that will also make it possible to keep the length of the curve really long enough. You know, it always starts from the very start point position to the very end. Yeah, that's really what I wanted. Okay. Now, there's obviously one problem here. The thing is that there are too much duplicated point position in this way, especially when you goes to the deeper loop. The later amount of the loops, the point will just stays on the very end point positions and not moving anymore. So for those points, we do want to trim these out. Okay. To do that, we could just use a node like fuse. So use fuse, and let's trim those points out. Now previously the point number was 400,000. Now by using a fuse node, it's now 10 or 100,000 points. Okay, it looks better. Okay, now the next thing I'd like to do now is to create the animation going from the start point position to the end point position for each of the curve primitive. Okay, so to do that, there are many options you can use. One of the options you can use easily is using the carve. I think. Let's see what happens with this one. By using carve, you can parameterize these value first U or maybe second U to shorten the primitive. Now this way goes from the very end to the very start. So maybe I can what's the best way? Actually, I want to start from these points, but starting from the very end. Right. Yeah, I guess this way. So starting from 1, 1 and decreasing the U value from 1 to 0, and then you'll be able to create this animation. Now the problem here is that it is possible, but it's a bit too slow, isn't it? I can see some glitches even though if I'm using these sliders. It's a bit slow. And why am I seeing these points as caches? Probably is a leftover points, not sure. Let me reopen the file, see if I can remove those points or not. Okay, let me reopen this. Okay, now the point's gone. It's good. So, as I said, using these carve is a bit too slow for me. Let me check. Using the performance monitor, and from the first frame to the 100th frame, changing the first U value using the frame. So 1 minus frame related value. Let's see what happens. See how much time do I need to calculate this. Okay. All right. So it was around 10 seconds. Okay. So let's see if I can use other method to make it a bit more faster. I'm not sure if it's gonna be possible, but let me check. Okay, so instead of using carve, I'm going to try to create a primitive from scratch. All right. So using a, first of all, I'm going to get the starting point position for each of those primitive by getting, what's the best way? Just gonna say primitive wrangle. And get the point list out of those primitive. And just get only the first point. And recreate this starting point, this point as a starting point. Okay, in order to do that, we need to get the position as well. And there you go. Oops, add point. And let's also remove the primitive. Okay, well, looks a bit strange. It looks like an endpoint, isn't it? So instead of getting the first point, let's try to get the last point position. Last point number. So is it the, yeah, I think this is the starting point position. Okay, so right now I have 1000 points, which is the number of primitive, and from this point I'm going to define where those points should go based on those frame number by referencing to the original curve together with function like frame UV. Right, so primitive wrangle or point wrangle. And referencing to this one as a second input. Then retrieve the point position based on those frame number. So first of all, let's create the flame related value called f by dividing the current frame integer value by the end frame number, and use that as a UV value of the primitive curve to get the point position based on those frames. So vector position is equal to prim UV getting the point position for each of the point, and 0, 0. And then move the point to that position. Okay. Now, finally, I'm going to try to use the trail to connect all those points within this frame to create a curve. Now, in order to do that, I do need to set an ID as well. So after I have added the point, let's set the ID attribute again. Just like this, retrieve from the primitive number. And try to add it as a curve. Maybe, I'm assuming this might be also a bit slow. So maybe just using carve makes sense. I haven't really tried this, so let's test. Okay, so I see a similar curve, which is similar to these carve. And see what happens in terms of the speed, performance. So going back to the performance monitor, click record and play. See how the speed goes, and it is what, around, where is it? It's around, where did it go? It's around, okay, so it's around 1 second, so it's faster, obviously. So maybe this, it might make sense in some cases. Alright, so that's good to know. Now let's also transfer the color, which was done right here. Maybe I can just bring the transfer color to right here. From the original geometry, which was this one. Okay, so now I have just created the trail going from the start point position to the end point, just like I want it. Nice. Yeah, it's running fine, I think. I kind of want to make these curves traveling at the same speed. Some of the curve is reaching to the end faster than the other one, maybe depending on the lengths. Maybe that's okay, I guess. Oh well, looks fine for now. Okay, now let's see, let's say this is okay, and now the final thing that I would like to do is to make this as a thickened pipe shape, to make it as a fiber. Okay, hello everybody, I'm looking at the comment, though I cannot really read what it says. Okay, thanks for all the comments. Okay, well, let me just continue. And so now the curve looks pretty, and it is going through on the surface equally distributed. So only thing I want to do now is to make it thickened using polywire or anything. And let's also define the thickness of each point. And probably the starting point and the end point should have the smaller thickness, and the points on the middle should have a more thicker. So in order to do that, I can apply some attributes like p scale. Alright, so let's do that. Now let me test that out using one of the primitive. So I'm gonna pick one of the primitive by selecting one random curve. Maybe I'm just gonna pick up the curve on the leg. Let's see how it looks like. Okay, now I have 100 points. And it seems like all those last of the points is at this end point. So all those 50 points or 60 points are being placed on this same point position. So we do want to fuse that. We do want to remove those duplicated points as well. Now I do want to do it right here, but there's a bit of problem because I don't actually want to merge this with other primitive points. I want to keep other primitives being unique points. So just gonna use the for each primitive to just fuse for each primitive. Now, and as in result, previously I had 100,000 points. I have 60,000 points. Now, due to using for each loop, probably from here I cannot really use this. I cannot use for the animation. So until here, this can be used for animation. I mean, the animation playback on top of the Houdini. But from here, probably animation playback is not fast enough because of this loop or because of creating a polyline. So polytube, I mean. So forget about creating animation for those part, but just try to create a static mesh. So let's see what happens right after I have fused all those points. Oops. Let's see what happens to these points. Does the point has been removed? So the total number of the point became 30, so that's good, I think. Previously it was 100. All right. Now, what was I trying to do? So now it's time to create a polywire, but let's use the point wrangle inside of for each loop to define the p scale for each point. So point wrangle, and let's also reorder those points based on the vertex order on top of the primitive, so that the point number is equal to the number which starts from the starting point to the end point. Sometimes it is not. So this is just to make sure that the point orders from start point of the primitive to the end point of the primitive. Okay, now it's time to change the p scale for those point based on the point number. First of all, I'm going to create a value going from 0 to 1 from start point to end point based on the point number divided by the total number of points, maybe subtract by 1 because we have we want to have a value in between 0 to 1. Okay, now we can now convert this value into an angle value by multiplying it by pi. Then I can use the sine function to make a value in between 0 to 1 with a wavy shape. And this is in between 0 to 1 again. So finally we can convert this sine value into a thickness, the actual p scale value. So let's have a maximum thickness or maximum radius. Okay, if it's 0, 1, well, okay, actually, I gotta also have to define the minimum value. Okay, now the maximum radius, let's try with 0.1. Maybe that's too big, but let's try. And finally, I'm going to apply this to a p scale attribute of each point. Okay, let's check this out. So if I look at the p scale, where is it? There you go. Let's see how the p scale looks like using a color node. Visualize these p scale with the color. So ram from attribute p scale, the maximum value is 0.1. So I can see that the start point position should be black. Is it? Cannot really tell. Maybe not. Maybe not. I don't know. Let's see. Let's see what happens if I use the poly wire with the p scale. And that might be too thick. So change this to 0.01. And let's also normalize. See what happens. Okay, so thinner at the starting point and the end point is what I want. It does look like what I want, I guess. It's a bit really noisy here. Maybe there's too much angle somewhere around here. But overall, is it looking okay? Not sure yet. If I change this to 2, I want to check what's happening in somewhere around here. So in order to check, I'm going to just pick one of those curve, selecting the primitive. Like that. Okay, so I guess this was causing a bit of problem, having this kind of angle. Now this was not that problematic. Maybe the other point. Hopefully I'll be able to find some problematic shape. Maybe this one. Or this one. Okay, oops. What did I do? I would just delete everything. Okay, what happens? Okay, so this is a good example having a bit of problem. So let's see if I can fix this. The problem is around here. Now, probably I can raise up the fuse ratio or fuse radius to fix those endpoint. It's a bit brute force way, but might work. Let's see. No, it looks a bit better, isn't it? Yep. Yeah, overall it looks getting fine. Now let's try to make it a bit more pipe-like shape or fiber-like shape by smoothing out the division, raising up the division number to make it a bit more pipe-like shape. Let's also delete the curve color value. Attribute, delete, remove the point color. Okay, not bad. It's already looking like a muscle fiber, isn't it? Especially those faces. Yeah, like it. Like it. Okay, now I guess it's going to make a bit more interesting by changing the radius randomly a little bit. So going back to the P scale, let's try to make this value randomize a little bit. So let's say I'm going to use the random function. For each point, is it? No, for each primitive in this case. So let's get the primitive number to use it as a seed value. So prim is point, no, wait a minute. In this case, we're inside a for loop, so the primitive number is always 0, so this cannot be used. So instead, I'm going to use the get the metadata, then use the iteration value as the seed value. Alright, so int iteration detail 1 iteration, and then use this with the random, maybe multiply by some custom values and so on. And then as a result, by using the random, you get the value in between 0 to 1. So let's refit this in between the minimum radius and the maximum radius. Okay, a lot of parentheses. Okay, show up the minimum radius. Let's make this 0.005. Oops, that was too big. 0.005. Now I have a thinner fiber at the same time a thicker fiber as well. Let's make it 0.005 to 0.003. Okay, looks nice. Maybe for the real muscles, it's not really random, but just to make things interesting. Okay, like it. If you want to raise up the number of fibers, you can just go back to the for each loop right here, which determines the number of wait a minute. The number of fibers is determined right here, the number of scattered points. So if I make this 3000, then you get 3000 curve in the end, the fibers in the end. Alright, more like it. Now it's getting slower. Yeah, it's pretty grotesque. Okay, make this 1500. And let me also color these strings or fibers randomly, maybe using black and white or something to make a bit more shades. So could be dependent on the thickness, could be a bit not really related to the thickness. I don't know, maybe let's try with first of all, I'm going to delete the color beforehand. Then inside this loop, I'm going to try to set the color. So CD B at CD is equal to this value right here. So fit value, which is in between minimum and maximum radius, into 0 and 1. Maybe I can just create the float color attribute and use this color attribute together with the color node, maybe outside the loop, to make it a bit faster. Okay, wait, no, that's not really what I wanted. That's not really what I wanted. Going back, and the things that I had to do is to make this value relied on the color. So let's go to let's create a radius value beforehand, radius variable right here beforehand, and bring this one right here, and then just have this one with a fit, which is in between minimum and maximum. So change this to 0.021. Okay, and going back to the thick end, I kind of want a little bit more darker areas, so let's bring this one to the right, and yeah, starting to see some it's a bit too noisy. Somewhere around here. Yeah. So in this case, smaller radius has darker color. I don't know if that makes sense, but looks okay for me. Alright. Not bad. Now, maybe additional setup for the thickness. I can use a power function for this sine value. So power and see what happens. Okay, so if I set this power to 2, you have the end edges or end point have more thinner edges. If it's 1, it's normal wave function. If it's 0.5, you have more thicker radius on the starting point. Maybe this looks okay. 1, maybe I'm just gonna keep it as 1. Okay, well, I do see a lot of messages, but I cannot really read what it's saying. Probably it's Russian. I don't know. Okay, so so far this is what I have created. First of all, created the curve animations going from the start point position to the end point position, like that. And then convert this into the muscle shape, muscle fiber. I could probably I could probably change. I'm not sure how much it cost using this one in terms of the animation. Let's see. Yeah, it's pretty slow. So this is what I got. And there you go. Yeah, if I try to play the pipe part, it's pretty slow. But the in-between process also looks pretty interesting. If you go to the very end frame, you get the whole shape being created as filled fiber shape. And you can also change this end frame as well, depending on how much you want to use the frame for the animation. And also defines the quality of the fiber as well. So higher frames you have, higher precision or higher high detail you have in terms of these fibers. Alright, that's pretty much it. Hopefully you find this interesting. Let me know if you have any comments. To what I have done so far, or any suggestions or any questions, anything. If you have any things, please let me know. If not, I'll just gonna end this right here and just end this. I have questioned, what about the seams? Okay, if you have seams, I think well, it really depends how it calculates the connectivity, you know. So if the geometry has seams, then you cannot really calculate the surface distance. So if you want to ignore those seams, then you either have to fuse it if the point is connected, or just recreate it as a whole one geometry, like using BDB or something. Let's see. let's try with a geometry that has seams, something like pig head. I think this one has a seam. I think. Forgot. Okay, so instead of the rubber toy, I choose the pig head. See what happens. So, and let's also try to change the initial point position to the x equal to 0 so that I can kind of see a symmetrical curve trail. See what happens. Now I'm not really sure if this pig head has actually a seam. Maybe not. But if you have a seam, then those seams will block these surface distance calculation, I think, since that those surfaces not connected, just like the rubber toy's leg part. Can I ask you a hypothetical question? Can I use your video in my ad as a reference? It's complicated. I'm not sure what you mean by ad. Advertisement, you mean? No, it is complicated. Can we discuss this? If you mean by advertisement, I think it's not really a good idea. If you mean by using as a your study for your own study purpose, I think it's totally fine. I mean the lines that divide the model on two hemispheres because of the symmetry of the end. Ah, okay, I see what you mean. So in this case, okay, it's not a good reference. Let me go back to the. Okay, so these part you were talking about. Well, this is inevitable, I guess, because the points for this, if you have the starting point from here, the end point is somewhere around right here. If you and the second point, if you have a second point somewhere around here, then the end point is somewhere on those edges. So if you are using this method, using the gradient of the distance, then you always have this kind of seam if you have two starting points. If you only have one single starting point, then you have less seams created, I guess. Let's try. If you have a single point as a starting point, then the result you get should have less seams, but yeah, you still got those. That is because you are using the distance gradient. If you want to remove those seams, then one thing you could do is to calculate or blur the gradient vectors after you have retrieved that. Going back to where you have calculated the gradient, somewhere around, where was it? Here. Okay. Let me first connect this to a new node. So that I can put a node in between the null node and the measure node. Just like that. And then use the attribute blur for the gradient and see what happens. And something weird happened. Let me increase the blur iterations to 5. Wow, I do still see seams and I am missing some head part. Well, that was because of the frame. Okay, so yeah, I guess you're still going to see those seams anyway. Or what if I make the blurring to the distance? Let's see what happens that. I haven't really tried, so I cannot really guess. Pretty much the same, so. If you use this gradient way, you still have this. I don't know, it's inevitable, I guess. And that's pretty much it. I guess maybe if you add some noise to the zero value. Noise to the zero value. Yeah. I am not sure which part you're talking about, but you could always try. Yeah. Please try yourself and let me know in the comment how it worked out for you. I'm not sure how I can do that for now. Cannot really imagine. And probably depending on your goal, the method should be different. Probably currently I'm not really, cannot really imagine what I would like to do for these seams, since I don't have much problem having those. It's really fine. So anything else in terms of the question? If not, I would like to end here. And as always, I am going to upload the file to the GitHub, and I'm going to paste the URL to the video description page so that you can download the file as your reference. Just use it for any purpose. Anything is fine, even for commercial, that's fine. Try to play with it, and hopefully you find this interesting in terms of the method. And I'm also doing some Patreon page, so if you're interested in this kind of tutorial, I'll be appreciated if you could support me on that page as well. Yeah, so that's pretty much it for tonight. Thank you for watching at this late time. It's a bit late today. I can probably do a another tutorial live stream next week, somewhere around Saturday or Sunday. I always make the late notice, so it's a bit hard for people to come in the right time, I guess. So I'm really sorry for that. Lately I am a bit busy changing my office. That's kind of a reason. Anyway, thank you for watching, and Thanks for all your comments. And that's it. Good night, and see you next week. Let me just end this one, showing this as a final picture. Wow, this is pretty grotesque. Let me take a screenshot of this one. I'm gonna post this on Twitter. I like it. Okay, let me also try this with rubber toy. For this one, and I'm gonna try to change the all right. Looks like a chewing gum rolled over. That's nice. Yup. Okay. Okay, that's about it, I think. Let me see what happens if I use an attribute. Yeah, the gradient attribute blur for the gradient makes this seems a bit smoother, I guess. So maybe this still does make sense a little bit. Yeah. Let me retake the screenshot, and this is the final result. Alright, so that's it. Thank you and good night.